covering how to use ping, traceroute, and how to incorporate this into Nmap scans. And finally, we'll be looking at a simple scan with Nmap. This is part 1 of 3 videos. Thank you. Right, so we're going to be using a TryHackme again for this one to help us with this. This is my target IP here, and I recommend this room for learning anyway. It's very good. Right, so let's get going then. So we're going to start with a quick ping, which basically tells us whether it's up or not. So ping and it is. So this could go on forever, but you can use Control-C to stop it, or you can do this to limit the amount. So let's say 2, oh whoops, sorry. It does 2 of them. You can do as many as you want here, but it's a good one to know. So yeah, you can use that to tell if devices are up or not on a network. Next, we're going to be looking at Traceroute. Traceroute is useful for identifying the path a packet will take to get to the destination. So let's say we're sending a packet to computer on a different subnet. First, our packet will have to go through the router and then to the final destination. So let's go. We'll use 10.244. This could take a little while. Still going, and we've reached the destination. So this is just a useful command for telling where a packet goes through to get to its destination. And we can incorporate both of these into Nmap. Right, so next we're going to be looking at how to see if a target is up using Nmap. So basically ping with Nmap instead. Alright, so basic syntax. So this is the default TryHackme server. Let's see if it's up. And the host is up. It's good to know. This could be used in reconnaissance when you're doing a pen test. Very useful. Next, we'll be looking at Traceroute with Nmap. All these commands can be incorporated into one. So we'll just run that. We've got it. See, so this also tells us which ports are open, which we'll be looking at in a bit. But we can see that this goes through 10.23.0.1 to get to its final destination, which could be used in the case of a pen test. The round trip time tells us how long it took to get here and how long here. Right, so next we'll be looking at how to scan a subnet. Scanning a subnet is useful when you're in the reconnaissance phase. It can basically tell us what devices are up, and we can further elaborate on that with further Nmap scans. So we're going to do this. This basically tells it to search for everything within the subnet. /24 would be the subnet of 256 devices. If we did /16, that would be all of the ones along. So that would be 256 times 256. Alright, so let's do /24 to see who's on the same subnet as us. Just tells us all the devices which are on this subnet of the TryHackme network. If this was the case of a pen test, we could then elaborate on each of these using Nmap or some other tool to find out further information about them. So this can be used on really anything. It's good, have a play about with these. Right, so next we'll be looking at PN. In the case of, let's say, a Windows device which drops packets, some of them do this, they're programmed with this to protect it from these sort of scans, then we can use -pn to ignore. So initially, Nmap will just check the host with a ping scan, but we can test this using -pn to tell it to ignore in the case that this device drops ICMP packets used by ping. So this device isn't up, but as it tells you, there is no response. So I'll show you both of these. This is just a normal Nmap scan. It tells us that the host was down. But then if we use this, tells it to ignore it. So in this case, it's not going to make a difference because the host is down, but it tells it to ignore the fact that there are no ICMP packets being received. I'll look at this in a later video. So next, finally, we're going to look at how to carry out actual scans with Nmap. This is where it gets good. Right, so here's our IP address. Scan. So basically what this is doing is scanning for ports. It's seeing which ports are open on the device. Let's say port 80 for HTTP, and it's telling us whether they're open. This is the very minimal, but as we can see on this device, we've got all of these ports open for a TCP connection. So POP3S, IMAPs, HTTP, etc. So we can play about with this. We can combine a few of them into one. So we can combine Traceroute. As you can see, it gives us Traceroute here using port 23, and it tells us that it went through here to get to here. Obviously this is the same as before, but I'm just showing you an example. We can also combine other ones with it, but for now we'll just move on. Right, so Nmap. We can specify what port to scan. This will come in useful later when we look at further examples of using Nmap with extra tools. So this is just telling it to only scan port 80, which is HTTP. So let's scan. It'll be quicker because obviously less ports to scan. And as you can see, it only scans that port, which could be useful if we were targeting certain ports. It speeds the process up once we know the minimum ports. Right, so thank you for watching part 1. We're going to look at a bit more of this, but we're going to move on to part 2, which gets more advanced. So there are multiple types of Nmap scan. There's SS and ST. So let's have a look at both of these. Right, so Nmap ST. This basically does a TCP connect scan. So let's just show you here. This is us. We're saying SYN. This is basically our way of telling it to connect. This is the target, which says SYN ACK. This is its way of responding, saying it's acknowledged. Then this is us saying ACK. So this basically does the full connection, the full TCP connection for ST. The issue with this is that it can be a little bit risky. Obviously because it completes the connection, so firewalls and all sorts of can detect this. So let's give it a run. As you can see, we've got the same results here, but obviously it used a different technique. Personally, I wouldn't use that. I would use -SS because this one is stealthy. Alright, so this is our SYN. The target goes SYN ACK, saying, hey, let's connect. And this is us going ACK, us RST ACK. So basically this does the same, but then it terminates it, so that then it doesn't make a full connection and is less detectable and far more stealthy. So let's give this a run. It's going to give us the same results, obviously, but it's good to know the different types. As you can see, it ran again. You're just using our different technique. So we've looked at both of these. Next, we're going to be looking at a UDP scan. Right, so first we need to look at TCP. TCP is what we've been doing so far with ST and SS. TCP basically creates a connection between the two of them. So it's like SYN, SYN-ACK, and then ACK. UDP, on the other hand, is known as fire and forget. Doesn't create a connection and is not connection orientated, so it will basically just send a packet. It doesn't ensure if it's arrived, it doesn't check, and it doesn't read. So UDP ports are different. These are ones like DNS, which is used for domain name service. Right, so let's have a look at this. We're going to scan for UDP ports next. We're using SU. Let's scan. This can take quite a bit longer, by the way, so I'm just going to pause you here. Hey ho, as you can see, it's identified UDP ports used. So these are open, these are closed. So as you can see, this one's open and willing to accept us to connect. Not obviously like TCP. So finally, we're going to look at a few techniques with Nmap. So we've covered the basic scans. We'll be looking at more advanced ones in part 3, my mistake. But we're going to look at a few techniques to speed things up, change the aggression, and depend on the version intensity. So let's just have a look at this. 10.10. Right, so this is just the usual, obviously, but we can add this to turn it into fast. Let's run. Whoops, I put in the wrong IP address there. Let's just fix that. All is good, not much difference here, but as you can see, it will have run faster. This is good if you're trying to run a fast one on, let's say, something that's got a lot of open ports. We can also use common ports. Ports 100 to say just scan these top 100 ports which are often open on devices. This can also significantly speed it up. And this was quite a bit faster than even the one before because it only scans the top known 100 ports. So next we're going to look at using version identity first. So let's say we're scanning this and we're looking at port 80, which is HTTP. We want to know what version the software is, so it's going to make a guess by using SV. As you can see, it's Nginx 1.22.1. This can be particularly useful when identifying software on ports which could be vulnerable, because this here we can search up on Google and see if it's a vulnerable version of the machine. So this is just a nice shorthand version. But next we can add one more thing, version intensity, to tell it how far to go in the search to find out the version, how deep it should look. So we're going to just say 1 here, which is the minimal, and let it scan, which will be faster. And it's gone a bit deeper into, less deep into searching it, sorry. But obviously it's no different, it's still got it right, or what we can think is right. So yeah, that's just a nice little thing to tell it how intense it should search the version of it. So one last thing I forgot to mention was using T to speed it up and slow it down. Right, so we can use T1 for slowest, T5 for fastest. So I'm going to tell it T5 here and run. It's run, it's a bit faster this time, but yeah, that's basically telling it to go the fastest it gets. T1 is the slowest it gets. Right, so next we're going to look into aggressive scans. Aggressive basically just means go full aggressive, but this could be an issue. This could cause us to be detected, so it's not always the right option. Maybe in a CTF use it, but yeah, let's have a look. this is going fully aggressive here. It's not going to do much difference, but yeah. And as you can see, it's run a lot of different commands on, which is very useful. -A, so it's told us the ports. It's run default script here. This can be useful to identify further things. The default script is basically a default set of Nmap scripts which can be run. It's taken a look at the OS, which we'll look at later, and it's used Traceroute, which we've looked at, so that's good. We'll also be taking a look at verbose. So basically 1v is saying minimal verbose, what we've just seen, but VVV, bit more verbose here, an extra V, very, and 5, the absolute maximum. So we'll just try 3 here, and as you can see, it's giving us a lot more details about what's going on. This can be useful. I typically use a setting of 2 or 3 when I'm doing CTFs, but it helps us see what's going on during the scan. And as you can see, there we go. So yeah, let's take a look at a couple of last things. So we're going to look at reason and operating system, 2 of my favourites. So we'll just use this, but let's use --reason. So basically, this has already used it here, but it tells us why it thinks the port is open. So in this case, it got a synac back, which basically means the server's responded, as we covered a minute ago. So we'll just use this basically here, and let's run. As you can see, it's given us a reason for all of them. Finally, as well as reason, another one of my favourites, very good in a CTF as well. If you're trying to identify the target machine, we'll use -O. -O basically means that it has a go at guessing the operating system, say Linux, Windows, etc. And yeah, so let's run. This will do a default scan as well as adding a guess at the operating system. So all of these different tools, very useful in different cases. I personally like to stick them all together into one command, which we'll take a look at in a moment. And as you can see, it's taken a guess at the OS. Not very good here, no exact OS matches for host. Sometimes in a CTF it will say like Linux, Windows, so on. So this basically just takes a guess at the OS. Right, so finally, in this video, we'll be back in later on for more advanced Nmap. We'll be looking at the one-line command that I would like to show you to put it all together. So here we have it. This is what I'd typically use. Sorry, -SC. It'll probably come up when I search it because I've used it. There we go. And yeah, let's change this. And as you can see, I've combined them all into one. So I'm using an SS scan, which as we've discussed is stealthy, -O to guess the operating system, VV for double verbose, not too much, but it gives us a bit of an insight, -T5 for T5 speed. This is what I like to use because it speeds it up. My machine's a bit slow with these scans. Reason to tell us the reason it's open. Traceroute to tell us where it goes through. Version intensity set to 5, which tells us to do a full version intensity check. SV, obviously version intensity, first place. -A is the aggressive scan, and -SC for default script. So let's run this beauty. And as you can see, it's given us quite a bit of verbose already. It's had a ping scan, as we looked at earlier, to check if it's up, and we looked at how you can ignore these with -PN in the case that it's blocking it and dropping it. And here we go, we've got some ports open here. Great. It's completed the SYN stealth scan, 1,000 total ports. Oh yeah, one last thing while this is running. You can use Nmap-P- to check every single port. So I'm not going to leave this running, it will take forever, but the point is you can check every port with this, because usually it will just check less than all of them, because obviously there's 65,000 possible ones it can be. That could take forever. But yeah, and this is using a default script. We'll look at scripts later on, and we've got a result. So let's have a look at this and analyze. Ooh. Right. There's a lot of information here. But here we have it. port 22 open, various others open. In the example of FTP being open, it'll tell us whether we can log in anonymously. And let's have a look down here at further. So look, OS fingerprint not ideal because insane was used, but if we use T1 that would maybe have a better guess, but it's probably Linux 3.1 is the guess, so 95%. That's good. And here we go, 2 hops to the destination through the router, and of course then on to the final destination, initiating the default script. And that's that really. That's all I've got today. I hope you enjoyed. One last thing, I would strongly recommend using this room to learn some Nmap, because obviously I told you a lot of basics, but the thing is there's a lot more detail in that. It might explain it a bit better than me. There's also live host discovery, which we covered a fair bit of. That's very good. This covers reverse DNS, which I didn't cover today. There's a bit more obviously, but I hope I helped. Thanks.